Good morning, everybody. Today we are going to focus on dual machine flow chart. It is very simple rules. The configuration today of the flow chart, it consists of two machines. Okay, the first machine and the second machine here. This is the physical configuration. There will be input here, and then after finish machine 1, the job will go to machine 2 and then come out of machine 2 as a finished good. This is the physical configuration of the dual machine flow chart. So actually we got a set of jobs to be processed on two different machines, and the objective that we have to do is minimize make span. As I already explained this objective to you maybe earlier in the class, it is the completion time of the last job. Okay, you need to find the last job in the system and try to find the configuration, try to find the completion time of it, and then that is become make span, and then find the sequence of job on both machines by using the Gantt chart. So according to the rules, the rule that you need to follow is Johnson's rule. Okay, for dual machine, for minimize make span of the dual machine flow chart. From the remaining job, we will show you the question later on. From the remaining job, the shortest time, if the shortest time is on the first machine, then you need to schedule that job as early as possible. That is, keep it left, okay, on your left hand side. Otherwise, put it on your right hand side. Okay, this is the position that you can put the job in. So if it is the shortest time of the remaining job is on the first machine, okay, put that job on your leftmost. Otherwise, put it on your rightmost. And once you already put the job in the position, so delete the job and then repeat procedure until you know remaining job is left. Two constraints that you have to follow. I think we go to the first one. Go to this one first. Okay, that is the capacity constraint. For the capacity constraint, I have already explained it to you last week. Says that there will be just only one job on the same machine at any time. So you can see at any time there will be just only one job. Okay, job 1, job 2. There will be no overlapping job here like this one. Okay, it's not feasible because each machine will will be able to process one job at any time. So this is the capacity constraint. Coming back to the precedent constraint. Okay, for the precedent constraint, it says that operation 1 of job must be finished before operation 2 can be started. Looking at this one, okay, the Gantt chart for dual machine flow chart, we have machine 1 here and machine 2 here. And this is the Gantt chart for machine 1, and this is the Gantt chart for machine 2. So please make a schedule for the first machine first, and then you can start make a schedule for the second machine later. So according to the precedent constraint, operation 1 of job 1 must be finished before operation 2 can be started. Look at this one. Okay, look at this example. You can see that job A operation 1 finished at this time. So its operation 2 cannot be started before this time. Right? Okay, so it could be start here or later after this point, but no earlier than this point. So this is for job A. For job B, okay, for job B, operation 1 finish here. So the second operation of job B cannot be started before this time. So the second operation of job B can be started after this time, right? Okay. So sometimes you have to put the idle time or waiting time between the operation because of the precedent constraint. Okay, this is the precedent constraint. Okay, capacity constraint. Okay, I will show you the example. So for this question, okay, you need to apply Johnson's rules for your machine flow chart scheduling. Sequence the following tasks onto machine A first and then B to minimize make span. We got 6 different jobs, job 1, 2, 3, 4, 5, 6, and we got 2 operation 1 and operation 2. Operation 1 is on machine 1, operation 2 is on machine 2. Okay, so because we got 6 jobs, so we have 6 different positions that you have to fill the job in. Now you need to find, okay, let me change the pointer in color to red one. Okay, so first you, according to the Johnson's rule, need to find the shortest time of the job, of the remaining job. Because the remaining job is 6 jobs, you need to find the shortest time. Shortest time is 1 here, and because the shortest time is on the second machine, then job 2 need to be put in the rightmost position. So in this case, put job 2 here and delete job 2 from further consideration, and then find the lowest operation time of the remaining job. This is 2, right? And because this one is on the first machine and is belonging to job 3, so in this case put job 3 on your leftmost position, delete it, and you got 2 choice. Okay, select it arbitrary. Okay, if you got more than 1 choice. Okay, in this case I select this one, right, because it's on the first machine. So put job 1 on your leftmost position, so it's here, put it here, delete it, and then job 4, right, it is on machine 2. Put job 4 on your rightmost position, put it here, and 4, 5, 8, 6, the lowest one is 4, and because it is on machine 1, put job 5 on the leftmost position. Job 5 is here, and only 1 remaining job, put it here because only 1 remaining position as well. So in this case the sequence will be 3, 1, 5, 6, 4, 2, 3, 1, 5, 6, 4, 2. Okay, you got the sequence that you can put it on the Gantt chart. And please note that the same sequence will be applied on both machines. So you got 2 different jobs, so you need to put 2 Gantt chart, machine 1 and machine 2. Okay, so please start from machine 1. Okay, make a schedule for machine 1 as compactly as possible and use the sequence 3, 1, 5, 6, 4, 2. Then, okay, starting from machine 1, the first job is 3. Job 3 require 2 units on machine 1, starting 0, finish at 2. And then machine 1 again, job 1 require 3. 2 plus 3 is 5. Then job 5 require 4. on machine 1. 5 plus 4 is 9, right? Okay. Then job 6 require 5 on machine 1. 9 plus 5 is 14. Then job 4 requires 7. 7 plus 14 is 21. And then the last one on machine 1 is job 2. Job 2 requires 6 units on machine 1. 21 plus 6 is 27. So once you complete the first machine, then you can go to the second machine. Before you go to the second machine, please make a dotted line, okay, to project from the first machine to the second machine, so that you can know you can notify the precedent constraint. Okay, 2, 5, 9, 14, 21, 27. Okay. The first operation on machine 1 is job 3. Job 3 cannot be started before 2 because of the precedent constraint. It could be started after 2. So in this case, earliest time that job 3 can be started is 2. And job 3 on machine 2 require 4 units. 2 plus 4 is 6, right? And then job 1. The first operation on job 1 finished at time 5, but it cannot be started at 5 because of the capacity constraint. So the earliest time that job 1 could be started is 6. So job 1 start at 6, and because job 1 require 8 time unit on the second machine, 8 plus 6 is 14 here. Then job 5 finish at 9. But you cannot start at 9 because of the capacity constraint. Again, so it could be start at 14. And because job 5 requires 8 on the second machine, 14 plus 8 is 22. Okay? And then job 6 finish at 14 on the first machine, and then job 6 could be start at 14. And again, because of the capacity constraint, job 6 can be start at 22. And job 6 requires 6 time unit. 22 plus 6 is 28. And the next one is job 4. Job 4 finish at 21 here. Because of the capacity constraint again, so you need to start job 4 at 28. Job 4 require 3. 28 plus 3 is 31. And then the last job is job 2. Job 2 finish at 27 on the first machine. But because of the capacity constraint, so it could be start at 31. And because job 2 require 1 unit. Okay, here. So 31 plus 1 is 32 here. So this is the last job on the second machine, that is the system. Okay, so the last job to be complete from the system at time 32. So in this case, 32 is the max span. So your answer would be the sequence of the dual machine flowchart will be 3, 1, 5, 6, 4, 2, and the max span is 32. Right? You need to find the sequence from the Johnson's rule, and then the max span can be found from manipulate the Gantt chart. Okay? Draw the Gantt chart. So your assignment today is about dual machine flowchart. There will be 6 jobs similar to our example, and we got 2 different machines as well. So you need to fill in the 6th position and then draw the Gantt chart to find the max span. Okay, good luck for your first assignment online. Thank you.